In this video, let's look at what a matrix polynomial is. So you know what a general polynomial is. So let us take an example of a polynomial defined on real numbers. So let f of x be a polynomial which is x square plus 2x plus 1. This is a quadratic polynomial defined on a set of numbers. So if you put different values for x, you get different values of the polynomial. It is f of 1 is equal to 1 square plus 2 into 1 plus 1. That is equal to 4. What is f of 2? F of 2 is 2 square plus 2 times 2 plus 1, which is equal to 9. So on. So whenever you have a polynomial defined on numbers, for different values of x, you get different values of the polynomial. Now, is this polynomial defined over the set of matrices also? So can I substitute x as a matrix and get some matrix as the answer? For example, if I take this polynomial and define over matrix A, f of A is equal to a square plus 2a plus 1. So this is not a valid polynomial on matrices because, so if you take A as a 2 by 2 matrix, 2, 1, 3, 2. So what is f of A? F of A is a square, that is the square of this matrix, which is also a 2 by 2 matrix, plus 2 times A is again a 2 by 2 matrix, plus 1. So matrix plus matrix is defined, but matrix plus scalar is not defined. So f of A is a square plus 2a plus 1 is not a polynomial which is defined over matrices. So to make a polynomial defined over matrices, so what we do is a square and 2a are not problematic. The problematic part is the constant. So whatever is the constant, I multiply it with I. So corresponding to this polynomial in numbers, I define a matrix polynomial is equal to a square plus 2a plus 1 times I, that is plus I. So whatever order A is, I is the corresponding order unit matrix. So the constant is multiplied by the matrix I to make a general polynomial a matrix polynomial. So an example of a matrix polynomial, you can think of x also, if x is a matrix. So f of x can be thought of as a naught times I plus a1 times the matrix x plus a2 times matrix x square plus so on plus an times the matrix x power n. So this is an example of a matrix polynomial. And to go to a specific example, f of x can be thought of as 2x square minus 5x plus 3i. This is a matrix polynomial. So if you take x as a matrix 1, 2, 1, 5, you can always calculate the value of this function or this polynomial if x is equal to 1, 2, 1, 5. So how you find this? So 2x square. So first find x square 1, 2, 1, 5 times 1, 2, 1, 5 is 1 plus 2, 3, 2 plus 10, 12, 1 plus 5, 6, 2 plus 25 is 27. So this is x square. So 2x square is 6, 24, 12, 54 minus 5 into x is 5, 10, 5, 25 plus 3 times I is 3003. So this is equal to, you can do the addition and subtraction according to the principles. So 6 minus 5 plus 3, that is 9 minus 5 is 4. 25 plus 0 minus 10 is 14. 12 minus 5 is 7. 54 minus 25 plus 3. 54 minus 25 is 29. Plus 3 is 32. So the value of this polynomial for this matrix 1, 2, 1, 5 is this matrix 4, 14, 7, 32. So what is the important thing that you need to understand here? So when you convert a polynomial into a corresponding matrix polynomial, the constant term has to be multiplied with ni of appropriate order. So let us take this very simple example. So f of x is x square plus 2x plus 5. A is the matrix 2, 1, 1, 3. We are asked to find the value of this polynomial at this matrix 2, 1, 1, 3. So this is a general polynomial. So what is the corresponding matrix polynomial for a 2 by 2 matrix? So f of a is nothing but a square plus 2a plus 5 times I of an order 2, because you're talking about a 2 by 2 matrix. So a square is 2, 1, 1, 3 times 2, 1, 1, 3, which is equal to 4 plus 1 is 5, 2 plus 3 is again equal to 5, 2 plus 3 is 5, 1 plus 9 is 10. This is a square. So what is f a? It is 5, 5, 5, 10 plus 2 times a. A is 2, 1, 1, 3. So 2 times a is 4, 2, 2, 6 plus 5 times I of order 2 is 5, 0, 0, 5. So that is equal to, so 5 plus 4 plus 5 is 14. 5 plus 2 plus 0 is 7. 5 plus 2 plus 0 is 7. 10 plus 6 plus 5 is 21. So this is the value of f of a.